Alright, hey there. So this is the notes review for Unit 2, again, for the semester 1 final. Again, if you feel like you don't need these, that's fine, but if you want to fill them in and just have them, that's okay. Alright, so Unit 2 was about, looking at functions, plugging in stuff, doing synthetic division, looking at the way the left side and the right side go on graphs. Alright, so when identifying intervals of increasing, decreasing, and constant, we only use the x values and use parentheses around both. Alright, that says be able to do the remainder theorem, use synthetic division, and that sort of stuff. Alright, so this is just doing synthetic division. Remember, this equals to 0, so we actually want to find the 0 to use. Remember, when you're doing synthetic division, put any placeholders in for the numbers if you need them. Remember, the first one drops down, and then just multiply the 2 every time. -2, 2, 4, 4, 8, 2, 4, 12. Okay, if there is a number at the end, remember that is a remainder. The other thing is, if you have your graphing calculator, you can put in x to the 5th minus 3x to the 4th plus 4x to the 3rd minus 6x plus 8. And if you go to second graph, look at the table. For the value of +2, you should have the value of 12, and that is the remainder. So when f is 2, the remainder, the y value, or the remainder, is 12. How do you know if a given binomial is a factor of it? Because the remainder is 0. Next thing, be able to break a polynomial down, determine the zeros, be able to determine the end behavior, use the 0, y-intercept, sketch a graph. During the final, you will have a calculator over the whole thing, so if you want to use a calculator, do combination of both, that's fine. Alright, so factor a polynomial by regular grouping, meaning regular just means having 2 sets of parentheses. Pull out the GCF. Alright, so part A, if a lead coefficient of a polynomial is positive, so this is for, and these A and B are for even functions. So x squared, x to the 4th, if the degree is even, then the right side goes up. For an even function, if the lead coefficient of a polynomial function is negative, then the right side, and coincidentally, left side, both go down. So again, A and B are for even functions, so if the degree is even, if the leading coefficient is positive, both sides go up. If the leading coefficient is negative, then both sides go down. Alright, so if the highest exponent is odd, then the left side does the opposite of the right. Okay, so if A is a positive, it'll go like that. If A is a negative, it will reverse. So if the leading coefficient is positive or negative, they're going to flip-flop. If the highest exponent is even, the left side does the same. So I just talked about that as the right. Repeated 0. Remember, if a 0 is repeated twice, the graph will bounce at the x-axis. So it won't go through, it will go bounce like that, or upside down. On the back side, be able to do long division and synthetic division, be able to write your answers correctly with the remainder. So write the polynomial like this. If it's a degree 1, I would just do synthetic division. So make x equals 0, solve for x, and then I would just do synthetic -8. I will look at the final and tell you next week about if the is a what is written and what is multiple choice kind of stuff, and -4, so that's a remainder. So I'm not sure if there's a long division problem on there or not, but I will check it out and let you know about that. So this starts as x to the 4th. When we do synthetic division, we go 1 degree down. So I have 2x cubed plus x squared, or 1x squared, minus 3x minus 2 plus -4 over x minus 5. I could definitely see something like this being able to write it on the written part, but I will double check for you. Be able to factor quadratics with complex zeros, be able to write the quadratic with the given zeros, be able to do this, then be able to determine the polynomial and this. Alright, given that 2i is the solution, remember they always occur in pairs, so -2i is also a 0. Write the remaining solutions and write the expression in factored form. Alright, so right now I know I have 2i and -2i. So, a couple different things you can do. You can go to y equals, clear off what you got and put it in there, and do synthetic division with any zeros you might find. Now, some zeros are not necessarily right there for you. Remember, this is a 4th degree polynomial because the biggest exponent is 4. Oh, look right there. I got 3 is a 0. So I can start synthetic division with that. Oh, I got another one right there, -4. Okay, you can start with 2i and -2i, but if 3 and -4 are also zeros, just show me that they work. So 3 is here, I got 1. I got 1 again, -8, 4, and -48. 1, 3, 4, 12, 4, -12, -8. And something's not right. What'd I do? 4, 3, 2, 1, 0, 3, 4, 12, 4, 2, positive 12 right there. 16, and then 48. There we go. I got a 0, which is what I need. Alright, so 3 works. The next one, -4, 1, -4, 0, 0, 4, -16, 0. That works. Alright, so if you want to, you can show this starts as x to the 4th, this is x to the 3rd, this is x squared. So I have x squared plus 4 is equal to 0. If I just solve it, x squared equals -4, square root of the square root, x equals plus or minus 2i. Okay, so I get all 4 of those answers. Factored form, just bring those back. So this means x equals all of those. So my factors are x minus 2i, x plus 2i, x minus 3, and x plus 4. Those are all my factors. Okay, so just a couple reminders here. And a degree with the nth degree will have n zeros. So if this is a 8th degree, it will have 8 zeros. They'll be real and complex, or just some of each. But complex roots always come in pairs, so a positive and a negative, because we are square rooting a number. A polynomial to the nth degree will have n minus 1 terms. So if the degree, so this is degree minus 1 is 3, it will have 3 minus 1 or 2 terms. Excuse me, and when using synthetic division, you know a value is an upper bound. Alright, so we're not worrying about the upper bounds and lower bounds. Don't worry about doing that. So the last page is Descartes' rule of signs. We're not even messing with that, so don't worry about that. Talk to you tomorrow. Bye.